Arden Labs, specializing in high-performance software consulting, training, staffing, and development. Module 10 channels. You are now watching Lesson 10.3, Fan Out.
We just finished looking at wait for a result, which is a base pattern, as I said, for patterns like fan out. So let's take a look at a fan out pattern while that wait for a result is still fresh in our minds. So we start there on line 64. There's our fan out function. And on line 65, what we're going to do is say that there are 2,000 employees that we're going to launch off to do some work. You know, the idea of a fan out pattern is just that. You have a bunch of work to do, a bunch of work. And so, you know, here's our Go routine. This is us. We're in some sort of path of execution. We realize that we have individual pieces of work we can do. We could do it ourselves, but we decide, no, we're going to go off and launch a Go routine maybe for every piece of work that's there. And then here's our point of guarantee. We're going to wait for all that work to come back. They're going to signal back when they're done, and then we get to move on. So that's the idea of the fan out pattern. And in this example here, we're going to have 2,000 pieces of work that we want to do. So we've set up the employees variable to be 2,000, and you can see the use of the buffered channel on line 66. So remember, the buffered channel means that we're not going to take the guarantee that a signal being sent has been received. We're moving the guarantee away from the signaling, right, the actual signaling mechanics, to outside of it. So we've got our channel. It's buffered. We're not going to have the guarantee. We're also going to signal with string data. And we go off and we launch those 2,000 Go routines on line 68. So there's our for loop. We have our literal function declaration. We have our function call. And we use Go. So now 2,000 Go routines are going off and doing the work that they already know how to do. We don't really know how long it's going to take to get any of that work done. And we're simulating that again on line 70 with the time. So while those Go routines are out doing their work, again, we're going to wait for all of the results, not just one, but all of the results to come back. So there we are on line 76. We start a loop saying when there is no more work to do, we'll be done, but while there is, we'll continue to loop. And then we block on line 77 in our channel receive, just like before. So here we are, we're waiting for work to come in, and suddenly these Go routines finish their work and they start to signal, right, send us that work. Now, because we've got the buffered channel, right, the channel is set up so every single sender, every single Go routine doesn't block on their send, at least as it relates to the receive. Remember, all we're doing is reducing latency between the send and the receive without the guarantee. But what if two or more Go routines want to execute line 71 at the same time? Then we have a synchronization problem again, and the channel will perform the synchronization. So we still may see latency on the send side, but it's not due to the receive, it's due to the fact that multiple sends are happening at the same time. But once that send gets to complete, it doesn't need a receiver on the other end to finish. The send happens before the receive. So there they are. There are Go routines on line 71, and they're performing their sends. They're putting data into the channel. They're signaling with their string data. And we're over there on line 77. We receive it. We decrement that local variable. That local variable is kind of working like a wait group, isn't it? It's giving us that local count on how many of these receives that we've finished. And once we get to all 2,000, then this code completes. So this is a typical fan out and the way you'd implement it. But what I need is for you to think about this for just a little bit. Fan out patterns are ridiculously dangerous because we could throw a lot of load on the system and at external systems at the same time. I mean, and you have to think about it at scale. Imagine we had a web service, and a web service that was running 50,000 Go routines at any given time. If we allowed those Go routines to perform fan out patterns, even if it was just 20 Go routines on the fan out, right? 50,000 times another 20 Go routines. You could see how many Go routines could be in flight at any given time. So I love fan out patterns for CLI tools, for cron jobs, maybe Lambda functions. But when it comes to kind of services, long-running services, web services, you got to be very careful about these fan-out patterns. They can put a lot of load on the system. They can do a lot of damage very quickly.